Hello, everyone. Thank you so much for joining us. We'll start the presentation in about 1 minute. Hello, everyone. Thank you so much once again for joining us. We'll start the presentation in about 30 seconds. Hello, everyone, and welcome to today's Safety and Health Magazine webcast, a blueprint for prevention, how to mitigate safety risks through human-centered design, sponsored by Cordy. This is Alan Ferguson, Associate Editor at Safety and Health, and I'm moderating today's event. Thank you so much for joining us. And before we get started, there are a few housekeeping items. As a disclaimer, the views of today's speaker are their own and do not necessarily affect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not mean the council of the magazine endorses those items. After today's presentation, we'll conduct a question and answer session with our speaker. If you have a question, click the Q&A button at the bottom of your screen, type your question, and press the send button. We welcome your questions at any time during today's event. You don't have to wait for the Q&A to begin. We might not get to every question, but the good news is unanswered questions will be forwarded to today's sponsors. Also, after this presentation, you'll be asked to complete a brief evaluation survey, and I'll tell you more about that a little bit later. Just to let you know, this webcast will be archived, so you can access it after today's live event to view this webcast and all of our past webcasts. Please visit safetyandhealthmagazine.com/events, or you may also receive a link in our post-event email. With that, let's introduce our speaker. With us today is Kim Mull. Kim is a product marketing manager supporting Cordy's ergonomic solutions. With more than 7 years of ergonomic consulting and research expertise, she has helped optimize and manage ergonomics programs for top organizations in a variety of sectors, including automotive, manufacturing, healthcare, and public services. Kim is also a Canadian certified professional ergonomist. Again, we thank you all for tuning in this presentation. Kim, whenever you're ready, go ahead and take it away.
Yeah, thanks, Alan, and welcome everyone to this webinar. I really appreciate you taking the time to join me today. So I'll get right into it. We're going to be talking about a few different topics during this session. To start, I'll give some background on what impact the design of work systems can have on safety outcomes and the consequences that can unfold when systems are poorly designed. Then we'll dive into why it's important to consider human factors and the way that systems are designed around people when managing risk. And then finally, we'll explore how design thinking can fit into a safety program and how you can leverage technology during the design process to ultimately improve the effectiveness of your risk management initiative. And then, like Alan mentioned, we'll do some questions at the end. So I was listening to a podcast a few weeks ago called Cautionary Tales with Tim Harford. And the episode is called The Vigilante and the Air Traffic Controller, if you're interested in checking it out. And in it, Tim shares a couple of true stories that illustrate what can happen when we have gaps between a system and the people who are interacting with it. And I thought it was really interesting and it aligns nicely with what we're discussing today. So I wanted to start out by just sharing with you a little bit about what happened in those cases and some of the complex factors involved that ultimately led to some significant consequences. So before we actually review those cases, I'd like to tell you about an important safety control in flying called TCAPs. Now, TCAPs stands for Traffic Avoidance Collision System. And this system comes into play where it appears that a mid-air collision might be possible between two aircraft. And it works completely independently from air traffic control. And air traffic control, they're the folks on the ground that are concerned with monitoring and controlling air traffic in the surrounding area. So what it does is it uses transponder signals between multiple in-flight aircraft to detect the potential danger of a mid-air collision based on the speeds and the altitudes of the planes that are close together. And TCAS will automatically notify each of the affected aircraft if it detects that they're too close together and provide instructions to the crews of each one on how they need to maneuver the plane to prevent a collision. So it will provide both visual and audible information to the crews to either climb or basically ascend in altitude or descend, ensuring that when their planes do cross, they don't actually meet. So one will be at a much higher altitude flying over the other if they were to cross paths. So again, I just want to give you a brief overview of what TCAS does because both of the cases that we're about to review involve this system. Okay, case number one. The first case is about how Japanese Airlines Flight 907 narrowly avoided a midair collision with Flight 958 in 2001. And if it weren't for a last-second maneuver actually performed by the crew of Flight 907, the planes would have collided. So what happened to that led to this near miss? TCAS, the system that we just reviewed, was functioning properly on each plane that day. And according to the flight plan, the two planes were supposed to pass each other with 2,000 feet of vertical separation, which is a safe distance, okay? Shortly after takeoff from the airport, the TCAS on Flight 907 was activated, instructing the crew to climb in altitude. So this, of course, indicates that it detected an impending collision. This is contrary, however, to the instructions that the crew received from air traffic control, who instructed them to descend. And these instructions were provided by an air traffic controller trainee who was working that day. And Flight 907 followed air traffic control's instructions, which actually put them on a collision course with 958, the other plane involved. And remember, I did say that TCAS was functioning properly that day. So what happened was that the air traffic control trainee actually intended to tell Flight 958 to descend, but gave 907 the instruction by accident. And in an attempt to help correct things, the trainee told 907 to turn right, but the message didn't get through. Then the supervisor jumped in, and while they intended to tell 907 to climb, they accidentally addressed Flight 957. But there was no Flight 957 in this case. It was a complete accident. So like I said, a last-second maneuver from the crew of 907 is what ended up ultimately preventing a collision. And fortunately, in this case, no one on either flight was killed. When we look at all the factors at play here, there obviously ended up being a combination of several gaps in the system that ultimately led to this near miss. Aside from the air traffic controllers mixing up the flight number, there was the decision by the pilot to follow the air traffic controller's instructions over TCAS. And it's important to note that at that time, there wasn't any clear rules in the rule book on what pilots should do when TCAS and air traffic control instructions contradict. Okay, so that's the first case. And then case number two. So the next case that we'll review unfortunately resulted in far more tragic consequences when two aircraft collided over Germany in 2002. And it ended up, the crash resulted in all passengers on one of the planes being killed, which was a commercial airline jet, and two crew members on the other also passed away, and that one was a cargo jet. So there's a passenger jet and a cargo jet involved here. And this is called the Uberlingen midair collision. Around the time of this accident, the cargo jet's flight crew requested permission to climb from air traffic control. And this was a typical maneuver to save fuel, and permission was granted by air traffic control. Shortly after that, the passenger jet contacted air traffic control, as they routinely would, and air traffic control acknowledged the flight, and they should have actually revised this flight path given the permission that they had just granted to the cargo jet, but for whatever reason, they didn't. And this put the two planes on a collision course. TCAS had kicked in at this point and gave each aircraft the appropriate instructions. But while TCAS told the passenger jet to climb and the cargo jet to descend, when air traffic control realized the impending collision, they instructed the passenger jet also to descend. The passenger jet followed those instructions, and this is what ultimately led to the collision. And upon further investigation, it was found that only one air traffic controller was patrolling at the time of the collision, and the other one, who was supposed to be on duty, was actually in another room sleeping. And this was common practice at that facility at the time, and it was tolerated by management, although it was against regulations. Also, a ground-based collision warning system, which would have alerted the air traffic controller of the pending collision about 2 minutes before the crash, was turned off for maintenance, and the air traffic controller was not aware of this. And lastly, an oral warning system released an audible warning to the air traffic controller's workstation prior to the collision, but it was not heard by the air traffic controller. And in hindsight, there was actually no way to go back and track as to whether or not the audible warning was even functioning at the time. So this is just another example to illustrate the perfect storm that can occur when gaps in the system line up in the wrong place at the wrong time. Many of you may have heard of the Swiss cheese model of accident causation, which was developed by psychologist James T. Reason. And it's a popular model that provides one way to visualize systematic breakdowns in situations like what we just reviewed. So for anyone unfamiliar with this model, picture a slice of Swiss cheese. It's covered with holes of varying sizes and random locations. And one slice represents one component of a safety system meant to defend against system failure or an accident. Each risk or threat to the overall system or a single point of failure is going to be represented by a hole in the cheese. So each individual component will have a number of holes or weaknesses, possibly. An overall safety system can be likened to a stack of Swiss cheese slices randomly placed on top of each other. System failure, or essentially an accident, occurs when one or more slices are stacked on top of each other and the holes momentarily align, allowing a hazard to pass through all the holes. In the second example we just went over, where there was a collision, there could be a slice to represent the TCAPs system, the air traffic controller working on duty, the pilot, the ground-based collision system, and the oral warning signal. And in this case, the holes in those individual systems aligned at the right moment to result in one massive system failure. And when investigating an incident like this, one might consider how to adjust the size or even the positions of the holes in each individual system to make them stronger, or by adding more layers of cheese or more individual system components to ultimately make the overall system stronger. An example of this is the two incidents that I just mentioned contributed to revisions to the TCAPs rulebook in 2003, where originally it was labeled as a backup system to air traffic control. It now has very clear guidelines for pilots to always follow TCAPs if TCAPs and air traffic control instructions are conflicting. And even, this control in isolation isn't perfect, right? It has holes because it relies on the pilot to comply with the rules. And some might think they're a pilot, it's their job to follow the rules and regulations to get from point A to point B safely. But anyone working, especially in safety, knows that mistakes happen that can result in really dangerous consequences under certain conditions. So it is why it's so important to consider how humans are interacting with the systems you have in place in order to really make sure that you're optimizing your safety strategy. When looking at the cases I just discussed, and quite frankly, many safety incidents that occur every day, we have to remember that humans aren't perfect, and our flaws have the potential to contribute to many holes in our slices of cheese or weaknesses in a system that ultimately lead to accidents. And in many cases with safety, when an accident occurred, it's our natural tendency to focus on the operator. So what did or didn't they do that led to the incident? And some organizations might be quick to chalk the cause of an incident up to a factor such as human error. And in safety investigations, we might see this otherwise phrased as carelessness, lack of attention, lack of situational awareness, non-compliance, or being distracted. But when we draw these conclusions and handle these types of accidents at the individual level through training or even some sort of corrective action, we're really restricting the scope of what we're focusing on and ignoring that there might be deeper issues within the system that led someone to make the decisions that they did. There's a really excellent book about this topic that I'd recommend to any safety professional called A Field Guide to Understanding Human Error, and this is by Sidney Dekker. And human error is put in quotation marks here on purpose. So Dekker suggests that human error is simply a label or a judgment we put on the behavior of an individual after an accident occurs. And there is really something to be said about the way that the author positions the evolution of thinking towards human error as it relates to the ways humans interact with the systems around them. So they break the views of human error into two. So they have the old view and the new view. In short, Dekker suggests that with the new view, instead of safety teams asking who was responsible for an outcome, they ask what is responsible for an outcome, particularly when there's an accident or an incident. And rather than seeing human error as the cause of an issue, they're a symptom of trouble deeper within the system. When we look back at our first examples, many of you might be wondering which individuals were at fault for each of those accidents after the investigation. But I would challenge you to take it up a level to consider all the system components that were involved. With the Uberlinger Midair collision, for example, was the second air traffic controller who went to go rest or go to sleep in another room negligent? Looking deeper, you might ask why management was turning a blind eye to this common practice. And why did air traffic controllers feel the need to rest during their shift in the first place? Was their schedule organized in a way that allowed them to get adequate levels of sleep? If we can reframe our thinking to consider some of these more systemic types of issues, we can leave the door open for implementing effective safety controls that go beyond relying on human behavior. And this line of thinking generally aligns when we look at the hierarchy of controls, right? So those less effective controls tend to be more common because they aren't as expensive or complicated to implement, especially in the short term. But when we're solely focusing on an operator's behavior in a safety investigation, for example, saying they were negligent or made a mistake or made an error, it will typically drive us to a lower order of control. If we diagnose the root cause of an investigation as the employee made an error, we'll be more likely to focus on those administrative controls towards the bottom of the triangle. We might think that as a solution, in that case, the rules need to be more clear or the employee needs additional training, which could be true to some degree. But if we ignore the other systems around them, then we're discounting the fact that errors can and likely will happen. And we're always going to have weaknesses in our systems. So it's all about looking how we can layer our Swiss cheese to either prevent the errors from happening or to introduce a level of recoverability in the event that an error does occur. And this is where human factors design comes into play. So let's look at the definition of human factors as positioned by the International Ergonomics Association. It's the scientific discipline concerned with the understanding of interactions among humans and other elements of a system, and the profession that applies theory, principles, data, and methods to design in order to optimize human well-being and overall system performance. So it's concerned with the interactions between humans and other elements of a system, and it is a design-driven discipline. And there are several domains that fall within human factors that make it a truly holistic discipline. So first, we have our physical factors, and this one is concerned with how human anatomical characteristics and biomechanics relate to physical activity. So when it comes to physical human factors within industry, we're often concerned with how the design of work and processes can result in musculoskeletal injuries, or kind of more of that traditional view of how ergonomics is perceived in industry. Next, we have the cognitive domain, and it looks at how mental processes such as perception, memory, reasoning, and motor response affect interactions among humans and other elements of the system. And relevant topics here might include decision-making, skilled performance, and human-computer, human-machine interaction. Then we have organizational factors, which look at how we can optimize our socio-technical systems, including organizational structures, policies, and processes for better interaction between people and their systems. And relevant functions here might include optimizing modes of communication, and how various programs and processes and policies are designed at a high level to improve the way that the system runs. An important thing to note is that all of these domains are very relevant when it comes to optimizing your safety risk management strategy. The consideration of human-centered design is not only going to help optimize your strategy for preventing ergonomic injuries, which is a very traditional view of human-centered design in industry, like I mentioned, but it can also lead you to look at the people-related factors that can lead to potential weaknesses in your safety system. So going back to when we are investigating a safety incident, not just asking who caused the accident, but again, digging deeper into how a person might have been interacting with the system that resulted in whatever behaviors were involved that caused that accident. Okay, so now I'd like to look at an example of, and this is a hypothetical example of how the outcome of an investigation could be impacted when we don't consider human-centered design. In this example, an explosion occurs at a plastic manufacturing facility and seriously injures 2 workers, and it nearly destroys an entire wing of the facility and all of the product housed within it. The smoke from the fire in this case was so prevalent that it forced a 2-day evacuation of the surrounding community. So just for some background on this facility, part of the manufacturing process is completed using reactors where materials are heated under pressure before transferring them to the next process. After a reactor is used, it's standard process to purge it of any hazardous gases and clean it using a pressure washer through an open manway. And the wash water is emptied through a drain valve at the bottom of the reactor. And this purge process is done completely manually. And there are 30 reactors within this facility that are all designed exactly the same. After this incident occurs, here's what the initial investigation revealed. On the day of the accident, a reactor had been purged and power washed, and an operator was going down to the equipment to complete the manual drain process. So they were going down to open the valve. But rather than going to the reactor that required draining, the operator took a wrong turn and approached an identical reactor that was in the middle of the reaction phase of the process. And when the operator attempted to open the valve, it didn't budge because the pressure within the reactor was too high, and there was a safety interlock that prevented it from opening. There was, however, a manual interlock bypass that the operator could activate in the case of an emergency. So, for example, if the pressure within the reactor was too high and needed to be released. So thinking that they were at the correct reactor and that the valve was just stuck, the operator used the manual bypass to override the safety interlock. The worker didn't contact the upstairs reactor operator or shift supervisor before doing this to check the status of the reactor. Once the valve was open, combustible vapor poured into the facility, and it was at that point that the supervisor came down to investigate after a deluge system was activated. And rather than evacuating the building, supervisors tried to take measures into their own hands, tried to take measures to slow the release of the materials, but they were unsuccessful, and the vapor eventually found an ignition source, which caused the explosion. And at first glance, based on the contributing factors that we have listed here, it might seem like common sense to chalk this incident up to the fact that the operator involved didn't follow the proper procedures or complete the appropriate checks. And if we draw that conclusion, this is what the risk mitigation strategy looks like. So we have providing refresher training to operators on standard safety procedures before enacting the manual bypass, and retrain supervisors on the evacuation policy and procedures. And it's not to say that these controls aren't important, but how else can we look at what happened in order to diagnose some of the more systemic issues that contributed to this incident? Because based on the solutions that they've come up with in this case, the assumption is that the system is sound, it's just the operators and supervisors who erred. So we want to try and challenge that way of thinking. We'll come back to that example in a minute. But one way to look at the application of human factors as it relates to safety is by considering how your work processes and overall systems are designed, because human factors is a very design-driven discipline. And in the interest of continuous improvement, adopting an iterative design process as it relates to safety gaps within your system can help to challenge you to really continually move your processes towards a state of optimization. And as new information emerges during the investigation, you can refine the design recommendations accordingly and continue going through the cycle. Here's what that process generally looks like. You might find slightly different variations of this model depending on what it's being applied to, but the high level steps will generally be the same. And it also might look familiar because there are other cyclical models like Six Sigma and Plan, Do, Check, Act that follow that very similar continuous improvement framework. So in this example, we have the 6 different stages. So first, defining the problem at the very top, then going clockwise, collecting and analyzing information, brainstorming and developing solutions, implementing the solutions, testing them, and then reevaluating the problem. And by methodically following these steps while taking a holistic view at the design of the entire system, we can start moving towards implementing more effective control. So let's go back now to our example and apply this model to see how it impacts the results of the investigation. For the define the problem stage, we'll consider the problems as being negative consequences that resulted from this incident. And in a more general sense, the problem could be in relation to single incident or a larger systems issue. So consider the magnitude of the impact. Does the problem affect an individual or a job or multiple staff or areas within an organization? In this case, the problem has an impact even outside of the organization because it led to an entire community having to evacuate. So the problem was defined as an explosion seriously injured 2 workers, damaged a warehouse full of product, and caused a 2-day evacuation of the surrounding area. You might want to refine this even further depending on how much detail you have up front and how much focus you want to place on a specific aspect of your design review. So an example of putting a little bit more detail in here would be the product was damaged, which resulted in $2 million in losses to the organization. For the collect and analyze information stage, in addition to collecting info related to what happened, similar to what I already went over, you'll want to try and understand why it happened. So what specifically led to a breakdown of the system? And to help investigate this, you want to collect data from a variety of sources that you're probably already used to. So including whatever objective data you have available, plus qualitative information from your people, both those who were directly involved with the incident, as well as others who performed their jobs. So getting lots of different perspectives. And try to investigate what physical, environmental, and organizational factors may have led to the workers' decision or behavior. And at this stage, it can be helpful to build a detailed timeline if you're able to. So some questions you might want to ask here are, what information was available to the worker at the time of the incident? what goals were they pursuing in their own words, what was going on in the process, and what were other people doing around them. And again, consider the design of the overall system. So you'll want to include what's going on with equipment, the processes, the procedures, and that human and system interaction. Identify any potential design flaws or gaps that may have contributed to the incident based on the information that you're collecting. So let's look at an example through the lens of, let's look at our example. So back to the plastic manufacturing facility through the lens of this human-centered design thinking for a moment. So not asking who caused this incident, but what caused this incident. Upon further investigation, it was found that all reactors look exactly the same, with few markings helping to distinguish them, other than a small number painted on the side. So when asking, the operator why they took a wrong turn, it really helps to explain that, well, it's really difficult to tell these reactors apart. There were also no formal indications of status of a reactor on the reactor floor. So the operator would have no way of knowing the status of whether or not it was in the reaction phase without going all the way back up to the control room. On the day of the incident, the frontline team was short-staffed, and the operator involved was feeling under extreme pressure to complete work duties faster than time usually allows. Also, operators on lower levels were not given radios. So had the operator decided to go up to the supervisor area to discuss the situation with the supposedly jammed valve, it would have taken additional time. They couldn't just radio up to the control room in 1 second and let them know. And again, like, they were already concerned with completing their work tasks on time. Lastly, the company had recently eliminated a group leader position, which gave more tasks to the supervisors and made them less available to deal with situations that came up on the reactor floor. While the organization recognized the human factors that play with this accident, they also acknowledged that developing a solution at the individual level by providing additional training or coaching was going to kind of just minimally address 1 or 2 weaknesses in a system that clearly has multiple gaps. So if we look at the stack of Swiss cheese, the fact that the operator and the supervisors didn't follow procedure with just 1 slice, they needed to look at how they could strengthen their system at multiple levels to help prevent something like this from happening again. And to do this, they engaged with a variety of stakeholders, including frontline workers, who were kind of their experts in doing those jobs, management, production engineering, maintenance, who would be involved with helping to implement and test some of the solutions, and a human factors subject matter expert as well. So here's what they decided to do at the develop solution stage. They repainted groupings of the reactors to differentiate their appearance and made their numbers larger and more visible. When an operator was sent to purge a reactor, they would be identified both by color and number, so it was much easier to tell the different reactors apart. And they had multiple ways of differentiating them as well. Status indicators were also installed on all reactors, so operators had a real-time reference on whether or not it was in the reaction phase while simply just standing beside it. So they didn't have to call up to the control room or go up to the control room to check anymore. And when looking at the design of the work processes, additional manpower was implemented both at the operator and the supervisor level. Management completed additional investigations to determine what could be done to mitigate perceptions of time pressure, or really to investigate whether or not this was focused on this individual, or whether other people within the organization felt that way as well, just with the interest of trying to promote safe work practices and people not rushing. Also, all operators who worked with reactors were provided with radios. So they were able to more easily communicate with the control room. And it's important to note, that you could do all these things and your system, of course, is still not going to be totally accident proof. Technically, you could have an individual ignore all the controls, or you could have a malfunction with one of the controls in your system. But of course, the more defense mechanisms you can put in place, the less likely you can decrease the likelihood of an accident occurring. So from there, the company implemented and tested the controls on a trial basis, where they received additional feedback on how they could further improve the system to support a safe work environment. So for example, a very simple problem came up where the radios purchased for the trial didn't properly transmit to the control room from a certain area of the plant. So after going through the design cycle process again, they found a different brand of radios that had better reach and worked from all areas of the facility. So that's just one example of how we can leverage a design-driven approach to mitigate safety risks, and especially to better control some of the human-related factors that can poke holes in your safety system. And if you're an organization who is interested in adopting this design-driven approach and looking at risk more holistically, technology can be leveraged to optimize your approach at various stages of the iterative design process. And I'm going to review now some ways that technology can be utilized to support a design-driven risk management strategy at a few different stages. Let's start with how technology can be used to optimize the first two stages in the design process. So we have defining the problem and collecting and analyzing information. Defining the problem effectively is a crucial step because it lays the foundation for the entire investigation and helps ensure that the investigation remains really focused and productive. Before defining the problem, it's essential to have a clear understanding of the system, product, or process that you're investigating. And at this stage, software can be used to leverage data in order to create visibility around common weaknesses within your system. So you want to have a good understanding of the current status of your safety system, because those metrics will be used as the baseline when you test your solution. By utilizing software to collect and aggregate leading and lagging indicators across a safety program, organizations have the ability to quickly and easily pull up reports when they initiate a design investigation to really help them understand how pervasive a problem is and to guide next steps. And to the same tune, software can help streamline your efforts at the collect analyze stage by enabling you to record and report on key safety program metrics all from one place. So oftentimes, we know that organizations have more data than they know what to do with. And if you have multiple sources of data stored in different locations, can make it virtually impossible to compare and analyze your information. So having all your safety data integrated within one solution improves the efficiency of data consolidation. So you're removing some of those administrative barriers. And the use of certain technologies like natural language processing can enable us to take unstructured data at a massive scale and turn it into a more structured model for easier analysis and decision-making. And what that type of technology does is it makes associations between written text and other data points. So we can easily find trends from documents, such as incident reports, to support decision-making without spending the time or effort that would be required to comb through each of those reports and trying to manually make those associations on our own. So through natural language processing, you can mine more data more quickly. And we can also leverage technology to get more people involved with this step. So it gives you a means to collect more data from a variety of stakeholders more quickly. So it just really improves the communication there. And you can get a broader, more holistic perspective than you would get from just a smaller team who might introduce their own biases and preferences to the design review. When it comes to looking at human-centered design and and design thinking, the greater variety of perspectives you can get is often a good thing. All right, let's move to the develop solution stage. So developing effective solutions in a safety design investigation requires a very systematic and thoughtful approach. At this point, your team should have an idea of what caused or is causing the problem. Like I said, engaging with multiple stakeholders across a variety of relevant departments is going to be key for effective brainstorming. And by including members of management, plus departments such as engineering, facilities, and of course, safety, it's going to be much easier to prioritize possible solutions based on both effectiveness and just the overall feasibility. And technology can help to optimize efforts at this stage as well. So for example, what if scenario analysis allows us to model the effects of unmitigated risk, but also the effects of potential controls or interventions to address these risks. So you can digitally model a work scenario and estimate what the likely outcome would be without any risk mitigation. And then you can compare that with different models of intervention to see which design solution is going to give you the greatest degree of risk mitigation at the lowest cost, at the lowest use of resources. And this enables decision makers to be much more pragmatic about using limited resources to implement a design change because they've already modeled it out. So you can do all of this before implementing and testing anything to make sure that you're really choosing the best solution to test out. And looking at more emerging technologies to support this stage, we have digital twins, which are real-time digital simulations of a physical asset, such as a piece of equipment. So you could take a 3D scan of the equipment, for example, and compare a digital representation of it to the idealized design. And if there were discrepancies between the current state and the idealized design, that might indicate a problem. And we are seeing this, we are seeing potential applications with digital twins to model and anticipate possible failure points and address them before anything gets actually put out in the field. You can also use digital twins to workshop different design ideas for mitigating the risk associated with a problem. And when it comes to implementing a solution, multiple departments will typically be involved as well. So it's key that you have an effective way to communicate. And by leveraging a digital solution geared towards safety program management, you can automatically assign out actions required to implement a solution. By using software to monitor the status of an action, you can have the full visibility over open actions, making for easier follow-ups, improved accountability, and the greater ability to react more quickly at the earliest sign of issues. And when it comes to testing or trialing a solution, you'll want to set up the trial such that you're testing your problem statement. So remember, in the earlier stages of the design process, you'll really want to establish the baseline for how you will measure success during the testing phase. For example, you might look at how the change impacts factors such as risk, usability, or cognitive workload required to complete a task or a job. And during testing, organizations can leverage software to manage the recording of test parameters, test results, observations, and any other relevant notes in a very structured and easily accessible format. And when testing is completed, you'll reevaluate whether or not the problem has been eliminated or reduced, or if new problems have been introduced as a result of the solutions that you've implemented, which can happen as well. So in any case where a problem persists, you can continuously improve on how you solution the issue by moving through that iterative design process as many times as needed. And we look at the entire iterative design process as a whole. Technology enables you to have centralized data history from the whole cycle. So if you ever wanted to audit your process, you could use a digital solution to draw relationships between different phases of the cycle when all of your data is housed in one place. And technology allows you to pull info and make associations in an efficient way. And like I've mentioned, you can use it to model and test out solutions in a way that really optimizes resource use before you physically have to implement anything or put significant resources towards implementing a solution. All right, and this brings us close to the end of the webinar today. So in closing, I'm just going to recap some of the main points that we discussed. So we learned that when completing a safety investigation, placing the cause of an incident on an individual can prevent you from uncovering issues deeper within your system. So I would challenge you to avoid drawing conclusions related to human error before completing further investigation as to why an incident may have occurred. Next, humans aren't perfect, and considering how human factors might impact the safety of a task, process, or system can enable you to develop more effective risk management solutions. Think about how you can design the systems around your people to improve safety performance, rather than trying to get your people to work themselves around your system. And lastly, incorporating iterative design thinking into your safety strategy is a way to continuously improve your system. And leveraging technology throughout the iterative design process can help streamline efforts to really guide smarter decision making. All right, and now I'd like to take this time to thank everyone for joining me today. If you would like to keep this conversation going, you're welcome to reach out to me directly through my email up there on the screen. And now I think it's time to open up the floor for some questions. So I'm going to hand it back over to Alan.
Oh, thank you so much, Kim, for this fantastic presentation. Before we start the Q&A, we want to remind everyone of the evaluation survey we're asking you to complete. The survey will open in a different screen after this webinar. Your input is important because it does help us improve our future webcast. And as a reminder to our attendees, if you'd like to ask a question, feel free to click the Q&A button at the bottom of your screen. And again, if we don't get to your question, all unanswered questions, we forward it along to our sponsor. And with that said, let's get to some questions. First, how can you bridge the gap between developing solutions and implementation when budget and/or resource constraints are an issue?
Yeah, it's a great question. This tends to be a common blocker in my experience, working as an ergonomist, and I know among other aspects of health and safety programs as well. So design changes that might have the most impact, as we know, can also be very expensive, depending on the nature of your workplace. But, as we know, injuries and incidents can be costly as well, and I think in more ways than one. So during the collect and analyze and develop solution stages, you'll really want to make sure that you're incorporating some sort of a cost benefit analysis activity where you're leveraging the data that you have to compare potential solutions. And then ultimately you can use that information to make a business case to management for implementing your design changes.
Our next question. If an individual repeatedly makes the same error, is it fair to draw conclusions of human error or negligence as a root cause if they've been educated multiple times on how to correct their behavior?
Good question. I think it's important in that case to really first look at the intent behind the individual's actions. So generally, folks, don't come to work each day with the intent of engaging in behaviors that could harm others or themselves. So if you have evidence to suggest that someone was purposefully engaging in unsafe acts, then maybe that's a different story. But if not, and you've educated them multiple times, you might want to dig deeper into the issue to determine what gaps could exist in the system. So for example, maybe in that case, there could be a mismatch between the job you're asking the operator to perform and their level of skill or experience. So it's just a matter of looking at the bigger picture there.
Our next question, should the design of safety systems start with the end user's bottom up rather than a top down approach of safety system design?
Yeah, that's a good question. I think depending who you ask, they'll have different perspectives on it. I think that in my experience, especially working in ergonomics, there is lots of evidence to suggest the benefit of taking that bottom-up approach. So, you know, the folks who are boots on the ground and are doing that work and doing those jobs, they are the experts in those jobs. So they kind of know that they're the best people to ask in terms of like the challenges that are being faced. I think that of course it's important to engage management as well, because you're going to need their buy-in often to implement any changes. But bottom up, I feel like is I can see certainly the benefits for bottom up in this type of activity.
Our next question, any tips on accurately and quickly evaluating the relevant features of the implementation and outcome of various risk mitigation approaches for comparison?
Yeah, good question. I'm just trying to wrap my head around here. So
Yeah, do you need to be repeated or?
yeah, do you mind?
No, not at all.
Thanks.
Any tips on accurately and quickly evaluating the relevant features of the implementation and outcome of various risk management approaches for comparison?
Okay, I'm going to do my best to answer this one, but if I am not answering it directly, just feel free to reach out to me and we can chat about it after. I think when it comes to being able to quickly evaluate an implementation and I guess the effectiveness of it, or whether or not it's a success, goes back to the data, the baseline data that you have available. So when you're defining your problem, you want to make sure that you can quantify as much as possible the impacts that data has to your organization. So I think like traditionally in safety, we look at things like risk, but when we're looking at those other human factors elements, so like the organizational factors and the environmental factors, there's other types of risk beyond just safety risk. So or not risk, but just other factors. So for example, the cognitive demand. So there are certain questionnaires out there that can help you assess before and after cognitive demand, you know, pre and post change, or time saving. So if there's feedback that workers are feeling rushed, then you could try and quantify impact of your countermeasure by looking at time savings. And sorry, if I didn't answer that, then please reach out to me after and we'll try and get to the bottom of your question.
Our next question, can you give more specifics on how to establish a solution to make sure it has helped? It seems like it may take a long time to see a reduction in incidents or near misses. Is there a quantitative way or is it just qualitative?
Yeah, good question. And it goes back to looking specifically at what your problem is. And depending on the problem and the data that you have available, it may be more of a long-term impact, but there might be more shorter-term impacts that you can quantify as well. So, so I'll try and give some examples. So like injury rate, for example, is more of a lagging indicator. And that one might have at least in ergonomics, it's usually like a slower onset. It's a longer term type of measure. So we might not see a change with that right away. But if you're collecting subjective feedback, such as, you know, you might be deploying questionnaires and asking folks about the level of physical demand on a job, that's something that you could collect right away. So you could collect that before you implement the change and afterwards to measure it. So, you know, again, kind of just back to the question, how you measure the change is going to be directly related to the problem that you're trying to evaluate.
Our next question, do you have a different approach to applying this methodology in general industry versus say construction?
Um, I, so the whole design thinking methodology, at a very high level is going to apply to any industry. I think that your organization is definitely going to, sorry, not your organization, but the industry that you're in is going to influence how that type of activity is managed at an individual level. So there isn't really anything that really sticks out to me in terms of how it would be different.
Our next question, how have you effectively dealt with the informal procedures that exist in workplaces? And as an aside, this question asker says, this is in relation to the example where one employee was sleeping at the time, which was customary and okay in the informal procedure, but against the formal procedure communicated.
Yeah, that's a really good one. So yeah, I guess like taking it from a design thinking perspective, it's almost looking at how can we engineer out the need for that procedure, if that makes sense. So how can we put more controls in place to ensure that more than, you know, all of the people who are there are working and you know, present. And so that could be, you know, maybe having like the computer doesn't operate unless like both people are signed in, or like something like that. There's a few ways that you could go about it, but that's the way that like I would look at it from that human factors perspective, is again just like how can we design the system around it to mitigate the need for people to be following procedures, because they're almost going to be like, I don't want to say forced, but controlled into doing what is required to complete the job safely.
Our next question, can you see AI technology being a part of the management solutions?
Yes, absolutely. And AI is relevant to some of the examples that I had mentioned. So for example, like the whole natural language processing is a form of AI where basically it will convert verbal information into more quantitative information. So you can make trends, associate trends between like different types of written text and reports and things like that. So that can be a huge time savings when it comes to making associations between all the information that you have available. Also, the what if analysis that I had mentioned is a form of AI. So like modeling around, building smart models around basically comparing different types of solutions and how they impact risk mitigation or other KPIs such as cost before you even have to implement, before you have to actually implement your control. Those are the ones that would stick out to me.
So I was just curious personally, when defining a problem or collecting and analyzing information, who should be involved throughout the organization?
That's a great question. So that's actually going back to the question about, is it going to be the same across different industries? And I guess when looking at that question, the answer is no, it might not be the same, because depending on who's going to be involved with actually implementing changes, who's going to be providing buy-off on changes, that's going to change. But I'll give you an example for like the automotive industry or like general manufacturing, because that's something that I have more experience in. So in that case, we'd certainly want the boots on the ground folks, the people who are working in the processes and on the line, to provide some information. It's not that they would necessarily be collecting the information, And sorry, just to back it up a second, were you talking about the collect analyze stage or the develop solution stage?
I believe the collecting and analyzing stage.
Gotcha. Okay, yes. So those folks will be good sources of information. They might not all be involved with helping you to collect information. Certainly your safety team is going to be helpful there. And again, like leveraging technology to compile risk information about different jobs, if risk is an issue, incident and injury rates, if that's an issue, and in which case you'll probably also want your OC health team to be involved if those are the folks who are who manage the administration of like tracking injuries and incidents and things like that. Depending on how technical a problem might be, you might want your engineers to come in and collect quantitative info, measure things on the process. And then also, oh, of course, how could I forget? Human factors experts would be very helpful here because they're going to know what types of metrics might be relevant just outside of your typical safety items that you might measure, like risk and exposure and things like that. So if you have human factors experts at your organization or even an ergonomist, and for those of you who don't know, human factors and ergonomics is relatively synonymous. So if you have an ergonomist on board, they might be able to help you out there as well.
Thank you so much. Unfortunately, we have run out of time today. Thank you once again to our awesome presenter, Kim Mole, everyone at Cordy, and of course, all of you who joined us today. Take care and have a safe day.